So this is just an introduction to polyatomic ions. Any chemistry textbook that you use, you're going to have a chart, a table filled with polyatomic ions. You should memorize them so that you don't have to think about them when you are naming compounds. You just kind of know it. So when you break apart the word, poly, many, atoms, but these are ions. So these are things that are put together and they have a charge. So you'll find cations, polyatomic cations, but there are very few of these. This is the +1 column, and it's a little weird. We've got ammonium. Don't confuse this with ammonia, right? Ammonium is NH4+, so one of those groups has a +1 charge. Hg2, you see it's 2+, but it goes in this column because that's actually mercury 1, because there are 2 mercury atoms, right? That makes it polyatomic, as long as we have more than one. So each mercury would have a charge of +1 for a total of +2. So this is called mercury 1, but it's always found paired up, and when it's paired up like this, it only has a +2 charge. So that's mercury 1. It's a little bit weird. You don't run into that a whole lot. We've got -1 ions. There are many of these. We've got hydroxide. That's pretty common. It's very basic. Nitrate, we have NO3 -1. Just be careful. I've seen students, they start using the 3 up here. There's a -1 ion with the NO3. We've got cyanide, which sounds pretty fun, or sounds toxic. But we've got C and N, we've got a minus, and MnO4- is permanganate. Something I'd like you to notice about the ions in this -1 chart. I've only listed 4, but you'll find this true when you look at other polyatomic ions. You're going to notice that there are some elements that have an even atomic number. So if you take a look at your periodic table, you look at the atomic number of oxygen is 8, right? But the atomic number of hydrogen is 1. And notice that's odd, and we end up with a -1 charge. We end up with an odd charge. Nitrate, we've got oxygen, which is atomic number 8, but nitrogen is atomic number 7, and there's only one of them. So this is all even. We've got one odd atom. One atom with an odd atomic number. So if you ever can remember that nitrate is NO3, but you're not sure about that charge, just take a look at the atomic numbers. When you see that that's odd, be like, oh, it's probably -1. And go with -1. Cyanide, same thing. We've got even, odd, -1. MnO4. You see a lot of polyatomic ions with oxygen in them, and oxygen has an even atomic number, but manganese does not. Manganese is element 25, and you see that it's -1. Okay, so that's the -1 column. -2, we've got carbonate, CO3 2-. Again, if you look at the periodic table, yes, oxygen's still even. Carbon is an even element, and it's a -2 ion. So even, and the charge is even. Sulfate, sulfur is an element 16. So we got a 2-. Chromate, element right. This is right next to manganese. This is element 24, and even charge, even atomic number, polyatomic ion, even charge. Dichromate, and we have peroxide. So these are just some -2 polyatomic ions you might run into when you're naming some compounds. -3, you don't have too many. -3, you have phosphate. One thing to notice, again, phosphorus is element 15, and phosphorus, it's an odd number. We've got -3. But that's the only one, so people usually don't mess up phosphorus a whole lot. Chlorine Oxy Anions. So if you see this term, oxy anions, that's just an oxygen-containing anion. And these are polyatomic ions, but there's a whole series. We have 4. Okay, so take a look. We've got perchlorate, ClO4-1. They're all -1. The charge is the same for each. ClO4-, ClO3, chlorate. If you notice, the ending is the same. Right? They still have the 8. Then ClO2, we have one fewer oxygen atoms, and now it's chlorite. Now we've got the ite ending. Okay, and then one less is hypochlorite. And this is the part of bleach that does its job. So hypochlorite is something that you'll hear about. But we've got this chlorine series. Perchlorate has the most oxygens on it. We go down to hypochlorite with the fewest. So this brings me to another thing, the connection between ate and ite. So if we look at many polyatomic ions, polyatomic anions, that have an ate ending, well, for one thing, you're going to see that there's some oxygen there. But if we have this ate ending, oftentimes there is an analogous polyatomic ion with one fewer oxygen atoms and the same charge, and a very similar name. So we have nitrite, right? If we change this ending from nitrate to nitrite, we have the same basic structure, but one less oxygen atom, one fewer oxygen atom, and still the -1 charge. So that's nitrite. Doesn't happen with these other ones, but we can go over, we can see sulfate. There's not just sulfate, there's sulfite. The only thing that changes in the name is that are those last 3 letters. And there's sulfite. So we just, instead of 4 oxygen atoms, we now have 3. So if you memorize the 8 forms of the polyatomic ions, like sulfate and nitrate, maybe phosphate, you will then know any ite forms that you come across. Same thing with chlorate and chlorite. So that's just polyatomic ions.